So practical 3, we're going to be isolating chlorophyll from some biological tissue, and then we're going to be asking you at the end of the practical to calculate the amount of chlorophyll that is present in your sample. So we've given you this as an example calculation in the pre-practical tutorial to have a go at. So on Thursday, your results table might look like something like this. So you'll have measured the absorbance at wavelength A and the absorbance at wavelength B, and then you'll have tried that at 3 different dilutions. So you might have had your undiluted chlorophyll extract, a times 10 dilution, and a times 100 dilution. So these are some example results that you might have. And if you remember, the absorbance peaks for chlorophyll A and chlorophyll B slightly overlap with each other. So we're measuring at the maximum for chlorophyll A absorbance, which is here, and the absorbance of chlorophyll B. And then we need a bit of a formula to work out how to get that into something biologically meaningful. Okay, so if we just think about what we've actually got in this table, okay, what we've measured is the absorbance at wavelength A. So if you remember, in the spectrophotometer, you've got light that goes into your sample, which is called the incident light, and then we measure the light that comes through the sample at the other end, and the ratio of those is the absorbance of your sample. So that's what you've got at the moment, and that's okay, but that's not really very biologically meaningful. How much does light go through a sample? That doesn't really mean very much. What we need is to convert that into something that's biologically sensible, and the biologically sensible thing to do is to determine the concentration. Okay, so concentration is the amount of something you have per unit volume. Okay, so you may have previously met concentration in terms of grams of something. So grams is an amount per litre, so that's what the -1 means, that's per. So grams per litre would be a unit of concentration. Now we're dealing with something quite small, so rather than grams per litre, that wouldn't be very sensible, we're using micrograms of our substance per milliliter. So that's going to be much more biologically sensible sort of a unit for us. Okay, so what we're doing is going from absorbance, from the amount of light that's passed through the sample, through to something biologically meaningful, which is a concentration. So in this leaf, I have X number of micrograms per milliliter. Okay, so to do this, we've given you some equations to do this. Now, these have been derived from primary experiments, and there's some conversion factors that we need in there. So we've given you these 2 equations, which might look a little bit scary to start with, but they're okay. So the amount of chlorophyll in micrograms per milliliter, those are the units we're using. We've got a conversion factor here, and then A at wavelength A, so that's the absorbance that we've measured at wavelength A. So this would be this 0.62 unit over here. Similarly, here we've got the absorbance at wavelength B, so that will be this 0.0552. So this is not what we set the spectrophotometer to, not the wavelength, it's the absorbance we measured at that wavelength. Okay, so that's somewhere where people sometimes go a bit wrong. Okay, so and when we've got the equivalent calculation for chlorophyll B. So I'm just going to go through the chlorophyll A one, and hopefully that will enable you to do the chlorophyll B calculation. So if we work through, so our equation says that the concentration of chlorophyll A in our extract in micrograms per milliliter is 12.25 times A absorbance at wavelength A minus 2.79 times the absorbance at wavelength B times by the dilution factor. Because obviously if we've diluted it, then we need to factor that into account in our calculations. Okay, so if we work through this, so first we'd say, so that 12.125 stays the same. A at wavelength A, so absorbance of wavelength A is this number here, 0.672. Okay, so we're going to times that in there. Then the 2.79 stays the same, and then absorbance of wavelength B is this 0.552. So we substitute that into our equation, and we're using the times 10 dilution. Okay, we can't use the undiluted because it was too concentrated for the spec. It gave us an error. And if we use a times 100 dilution, it's going to be less accurate. So for this one, we're going to use the times 10 dilution. So we've now substituted in those values. Then we can say, we'll just do the equation, so 12.25 times 0.62, that's 8.232, and then 2.79 times 0.552, that's 1.54. So we've got 8.2 and a bit minus 1.5 and a bit times 10, So if we do that, so that's 6.69 times 10. So our final answer should be 66.9 micrograms per milliliter. So that's got us from these absorbance values, which aren't terribly useful, through to something that has some biological meaning. So that's the math that you need to do for chlorophyll A. So have a go through that, make sure you understand it, and then have a go at chlorophyll B, which is the last question in the pre-practical quiz.